Welcome back to my YouTube channel Sriram Devarajan. In this video I am going to discuss Madras University question paper April 2026. This is part of previous year question paper series for the subject Allied Mathematics 1. I am going to discuss part C problem from the topic differential calculus. I am going to discuss problem number 23. This problem from part C, topic is differential calculus for 10 mark. The problem is given as if y equal to sine of m sine inverse of x, then we have to prove 1 minus x square y2 minus xy1 plus m square y equal to 0. Then 1 minus x square yn plus 2 minus of 2n plus 1 xy n plus 1 minus of n square minus m square yn equal to 0. We have to prove two equation. This is equation 1, this is equation 2. Solution. What is given? Y equal to sine m sine inverse of x. Differentiate with respect to x. Y becomes y1 sine of m sine inverse of x. If we take this one as x, differentiation of sine x cos x. Here cos m sine inverse of x, differentiation of m into sine inverse of x, 1 by root of 1 minus x square. Differentiation of sine x is cos x. Here cos, in place of x we have m sine inverse of x. Differentiation of m sine inverse of x, it becomes m into 1 by root of 1 minus x square. Cross multiplying root of 1 minus x square into y1, which is equal to m cos m sine inverse of x. Squaring on both sides, we get it becomes 1 minus x square y1 square m square cos square m sine inverse of x. We know very well cos square theta 1 minus sine square theta. Here 1 minus sine square m sine inverse of x, that is nothing but m square 1 minus y square, because sine m sine inverse of x is our y. Therefore from A I am replacing sine square m sine inverse of x as y square. 1 minus x square y1 square minus of m square 1 minus y square equal to 0. Again differentiating with respect to x, 1 minus x square, I am applying uv. uv means uv dash plus vu dash. 1 minus x square 2y1, differentiation of y1, it becomes y2 plus y1 square, differentiation of 1 minus x square minus 2x minus of m square minus of 2y y1. M square as it is, differentiation of 1 minus y square minus 2y, differentiation of y, it becomes y1 equal to 0. Divide by 2y1 on both sides. It becomes 1 minus y square into y2 plus x minus of x y1 plus m square y equal to 0, 1 minus x square y2 minus of x y1 plus m square y equal to 0. This is our first equation. 1 minus x square y2 minus xy1 plus m square y. Now I am going to prove the second equation from 1. From 1, apply Leibniz theorem. We get the equation 2. We get that is d power n of 1 minus x square y2 minus d power n of x y1 plus m square d power n of y equal to 0. First write the Leibniz theorem formula. That is d power n of uv, which is equal to d power n of u into v plus nc1 d power n minus 1 of u into d of v plus nc2 d power n minus 2 of u into d square v plus dot 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 plus u d power n of v. This is the formula Leibniz theorem. I am going to apply Leibniz theorem for each term in equation 1. First term d power n 1 minus x square y2, second term d power n xyn xy1, last term m square d power n of y. What is first term? D power n of 1 minus x square y2. V 1 minus x square d of v minus 2x d square of v minus 2. What is u? U is y2. D power n of u y n plus 2 d power n minus 1 of u y n minus 1 plus 2 y n plus 1 d power n minus 2 of u, that is nothing but y n minus 2 plus 2 yn. This is d power n minus 2 of u, this is d power n minus 1 of u, this is d power n of u. Substitute all these in star. That is our Leibniz theorem. Star implies formula d power n of u. D power n of u is y n plus 2 v. What is v? 1 minus x square. nc1 means n by 1 factorial. D power n minus 1 of u y n plus 1 minus 2x plus n into n minus 1 by 2 factorial yn minus 2. Simplification: yn plus 2 1 minus x square, 1 factorial is 1 minus 2nxy n plus 1, 2 cancel, plus into minus, minus of n into n minus 1 yn. This is equation B. Now I am going to find the value for d power n of xy1. Here v is x, d of v, differentiation of v for x1. U is y1. What is d power n of u? Yn plus 1. Substitute all this in Leibniz theorem. D power n of u yn plus 1 into v is x, plus n by 1 factorial d power n minus d power n minus 1 of u yn minus 1 plus 1. Minus 1 plus 1 cancel, simply yn. This is d power n minus 1 of u, that is yn into 1. Simplify xyn plus 1, 1 factorial is 1, yn. This is equation C. Last term in star, that is last term here this is double star. Last term in double star, m square d power n of y. M square d power n of y is m square yn. This is d. Substitute b, c, d in double star. This is equivalent to d power n 1 minus x square y2. What is the answer? This term. This is b. D power n xy1. What is the answer? Equation C. M square d power n of y. What is the answer? M square yn. Therefore 1 minus x square yn plus 2 plus n yn plus 1 minus 2x plus n into n minus 1 into minus 1. What about C equation? Here we have minus, then we have plus. Minus of xyn plus 1 plus nyn plus m square yn equal to 0. Now simplify 1 minus x square yn plus 2. Here minus of 2n xyn plus 1. Here minus of xyn plus 1. Here plus into minus n square. Here last term I am missing one term, yn. N into n square yn minus plus minus of minus plus nyn. Now minus plus minus nyn plus m square yn equal to 0. Minus nyn plus nyn cancel. Therefore, remaining term 1 minus x square yn plus 2 minus of 2n minus 1. Take minus outside. 2n plus 1 xy n plus 1. Here m square yn, here minus n square yn, plus of m square minus n square yn equal to 0. I am going to check the final answer from equation 2. 1 minus x square yn plus 2 minus of 2n plus 1 xyn plus 1. Here we have to write them as minus of n square minus m square yn. I am simplifying from this. First term okay, second term okay. For plus m square minus n square yn, I am written as minus of n square minus m square yn. This is the final answer for the problem number 23rd from the topic differential calculus from part C. I have finished all the problem from the question paper April 2026, part of previous question paper series. I will upload remaining question paper in the upcoming video. If you like this video, share it with your friend, subscribe it for more videos. Thank you for watching. Happy learning.